Okay, welcome to week 4, part 2. In this lecture, we're going to take a look at interacting with an SQL relational database from within Python. I'm going to skip these review questions here. Okay, so relational databases are probably the most popular kind of databases out in the world. There are other kinds of databases as well. And relational databases pretty universally support this language called SQL, which is an acronym for Structured Query Language. All different databases, SQLs, are like 90% the same in terms of the basic capabilities that they offer. They all do have some differences. So if you find yourself needing to work with multiple different kinds of SQL databases, there will be some annoying differences that you have to learn. So an advantage of using a database to manage your data is that it is a very stable and well-tested and robust bit of software that you are not responsible for having to debug. You just install the thing and use it. SQL itself, as I said, it's described as being standard here, and it is pretty standard, not 100% identical across all different kinds of relational databases. Using so-called normalized tables, which is tables that don't contain multiple copies of redundant data, improves the reliability of managing the information for your program. Now, some disadvantages are that accessing information from a database is likely to be slower than if you have the information you need, for example, directly in an ND array in NumPy. And SQL has limitations. For example, pretty much anything you do in SQL is going to involve interacting with tables of information. It's much more difficult to deal with individual values within SQL. Here's just a list of some commercial and freeware relational database systems. We are going to be making use of SQL. I'm not sure how this is pronounced. SQLite. I'm not sure. Because it's just part of it comes with Python, so you don't have to go out and download anything and install anything in order to be able to use it. So a table is the primary data structure, if that's the right term, within a relational database. Each row is a record or tuple containing information, and each column specifies a particular attribute. So if this is sounding very similar to a pandas data frame, you are right. Okay, so columns are attributes or fields. Rows are individual records. One column will be, or perhaps sometimes a collection of columns, is the key that uniquely identifies each record within the table. It's also possible to have what's called a foreign key, which is a key found in some other table that enables you to link together or join together the information contained within the current table and that other table that has this foreign key. An index is simply a mapping from a key to a particular record number, and indexes can be created to provide more efficient access to information that you use frequently. Okay, so basically we have in SQL mechanisms for selecting rows, mechanisms for selecting columns, and also mechanisms for joining together information from multiple tables to create new tables. Here is the very top-level syntax for a so-called select statement in SQL. And basically what we're doing is we are selecting a certain column or some collection of certain columns from a table. In fact, you can select columns from one or more tables. And then the where clause here has various Boolean conditions that identify which rows you want to select from the tables. Okay, so select certain columns from tables where some Boolean condition is true, like select all the employees from the employee data table where the salary is greater than 85,000, let's say, something like that. Here's a little more complete example. In this case, we're assuming that we have two tables defined within our database. The first table is called employee, and within the employee, there are 5 columns in each row. So we have, for each row, we have a first name, a last name, a unique ID number, and because that ID number is unique, we're using that as the key for this table. We also have a salary and a department ID that the employee belongs to. This department ID is a foreign key because it is used as the primary key in a second table we have, which is called the department table. And in the department table, we have each row consists of a department ID. This is the unique key. And for each department, we have a name and we have a location. Now, why do we have this split into 2 separate tables? Why don't we just have an employee table in which we have, for each employee, the first name, the last name, the employee's ID, the salary, the department ID, the department name, the department location? Well, the reason we don't just blend all of that information together into one giant table is that suppose you have a department that has 15 employees in it, and the department changes to a different location. Well, now you have to go through your employee table and you have to change the department location for every employee in the same department to this new location. And it's going to be very easy to mess that up and to leave some employees in their departments in one location and some employees with their departments in some old location, let's say. So we want to separate out we want to separate out redundant information into its own table. Okay, now if we have these 2 tables, we can, for example, select the last name and the salary. Those are the 2 attributes that we want to select from this employee table where the salary is greater than 50,000. And what we get out is a table. All right, so we're doing a selection from one or more tables, and what we get out is a table. And the column names are the column names that we requested, and then we have rows specifying the values of individual records. Here's a little bit more complex example. This time we're selecting department name, last name, and location, and we are joining. I don't seem to be able to highlight the title, but we're joining the 2 tables together. So we're selecting department name, last name, and location from employee and department, where the department ID for the employee is matched with the department ID in the department table. This way, for each record coming from the employee table, we get the name of the department that they belong with, the last name of the individual employee, and we also get, by joining with the department table, the location of that particular department. Here's a updated way of accomplishing the same thing. This time, instead of just referring to two separate tables and implicitly assuming that that SQL is going to join them, we can actually use a join keyword. So again, select department name, last name, and location from employee joined with the department table, where the employee's department ID is the same as the department's department ID. Now, I do want to point out, by the way, minor point, trivial thing, but in Python, to do an equality test, use a double equal sign. In SQL, you use a single equal sign to do an equality comparison. Okay. And I don't want to walk through this this collection of different kinds of joins. I'll let you muddle through that yourself. Anyway, before we can interact with a table, of course, we have to have a table. And we can create a table by using the create table SQL statement. The purpose of doing this create table is to retain a copy of the table that we got resulting from the select operation that we did. Okay, so this time around we are creating a table called department employee, dept-emp, and the word as means that what we want to put into this newly created table is the result that we're getting from this select statement that we just described. Okay, so that was some hand-wavy introduction to basic SQL select statements, and we showed one create statement that created a new table. We're going to take a look at the Sqlite relational database that we have with Python. Okay, there are other relational, I mean, essentially any relational database that's out there is going to have some module or collection of modules that you can install and make use of to interact with those databases. But we'll just use Sqlite as an example. So I'm going to import Sqlite version 3, Sqlite 3. And now I need to connect to the particular database that I want to make use of. A database may have many tables within it. All right, so here the database name is mydb.sqlite, and this database does not already exist. I have not created this database yet. So the first time I connect to this database, it's actually going to create a database with that name. So I'm going to make a connection to the mydb.sqlite database. Okay, and let me show that really did create my database for me. If I can pull up my... Here we go. Whoops, where'd it go? Oh! I think I know the problem here. I haven't. Oh yeah, there it is. I just didn't. It was stored in alphabetical order, so it was too hard for me to find. All right, so there's my Sqlite database, and as you can see, 0KB. It's empty at this point. All right, now a cursor provides me with a sort of a pointer or reference for interacting with this database system. What's the analogy here? Well, if we think in terms of files, then this connect function essentially would be like creating the file. All right, so this connect function here is creating the file, and then asking for the cursor is going to give me a pointer or a reference through which I can actually issue commands to that database. And so let me do that. So I'm going to get my cursor. Whoop, cursor op. Nope. There we go. Of course, creating a connection to a database may fail. In the case of a brand new database, you may not have permission to create a file in the location that you are wanting to. Or if you're trying to open an existing database, that may fail for lack of read permission or something along those lines. So in real life, if we were going to create a real program to do this, we really ought to set up a try and accept to make sure that the connection does actually work. But we're not going to worry about that for now. Okay. Once I have a cursor, I can now execute SQL commands by using the execute method. So I can say cursor.execute, for example, a select statement or a create table or something along those lines. Well, we do have a database, but the database is empty. We don't have any tables in it yet. So we're going to create a table. We have to specify the names of the columns in the table, and we have to specify the data types of those columns. And the data types are vaguely like Python, but not exactly the same. For example, we have integer columns, we have varchar columns, variable character columns with some maximum length, which you can think of as being sort of like a fixed size maximum length string. And we have float values and real values and lots of others. These SQL statements that you're executing may be very long. It's common for a SQL select statement or a create table statement to be, like a dozen lines long or something. So it's not a bad idea to use, for example, triple quotes to contain the full text. Okay, now, so as I said, in our case, the database doesn't exist, and consequently, the connect statement that I issued creates it. If the database does already exist, you are going to be reading and writing from it, so you have to be very careful not to destroy the tables that are already in there, destroy the data that's already in there, what have you. A real database typically is going to have a whole lot of tables. Okay, so if you have a company representing if you have a database representing a company, then you're going to have tables for all the employees in the company, tables for all the customers of the company, tables for all the products that the company sells, tables for the various departments in the company, tables for the financial records of the company, on and on and on. And you can find out the names of all of the tables that your database knows about by saying select name from Sqlite master. So Sqlite master is like a top-level magic term where type equals table, and you'll get a list of the tables that exist. Well, we don't have any tables yet, so we won't do that yet. But let us create a table for employees of our company. And to protect ourselves from wrecking an existing table, notice that we're going to say create table, but only if the table doesn't already exist. So create the table if the table doesn't exist, called employees. And in here, we're going to have 8 columns. The employee number is going to be a 4-digit number, integer value. And we're also marking that as the primary key for this table. The last name can be up to 20 characters long, first name up to 15 characters long, job up to 9 characters long. The date of hiring is a date. Department number is a 2-digit number and can't be blank. All right, so some of these are going to be allowed to be blank. For example, maybe we have an employee, maybe we've hired Cher. And so Cher has a first name but not a last name, and so the last name field might be blank there, okay? But the department number cannot be left empty. The monthly salary is given here, and also the ID number for the manager is given here. So manager is also a 4-digit number that has to correspond to some existing employee. Well, let me copy and paste this whole. Actually, I have this in a separate code file, so I'm going to copy and paste it from here. Here's my table query that contains this giant create table SQL code, and I'm going to execute that so that now I have this table query string established. Well, all right, all that did was to create the command as a string. I would like to actually execute that command, and here's where our execute method comes in. So on the cursor, which enables me to talk to my, or through which I can talk to my database, notice these various methods that exist, and one of these is execute. I'm going to say execute the table query. Okay. So that did create the table query, and I got told, all right, we have a cursor for that table. There's no data in there yet, so I would like to insert some new data into the table. And I can either do this by setting up a long list of a whole bunch of insert statements, or I could set up a list of lists in Python and then iterate through that list of lists with a for loop. When I'm all done, in SQL and SQL, I have to execute a commit command to indicate that I want all of the requested changes that I have made to actually be saved. If you forget to do the commit, then the creation and inserting and so forth that you've done may just vanish if your connection to your database goes down. All right, so here is a list of individual insert commands. I'm saying insert into employees, insert into this table called employees that I just created. This tuple of values. And notice that the values have to be in the same order as the columns that I requested to be created. So the employee number comes first, then we have the last name, the first name, and the job name. Then we have the hire date and the department number, monthly salary, and manager. Now, this first person here, Ben King, is the big boss, and Ben King has no manager. So we're using the special value null to indicate Ben King's manager. Notice that Ben King's ID number is 7839, and the next three employees that we're creating report to Ben. This fifth employee that we're creating reports to Larry. Okay, so we have a shallow hierarchy here with Ben King as the big boss, and then Larry, Sam, and Jim reporting to Ben, and Sue reporting to Larry. All right, now I have that list of insert statements also in my file here. So let me copy these. There we go. And now I'm going to loop through each of the items in this data list and execute each one of these items. So this is 5 insert into employees statements, and I'm going to execute those one by one. For item in data, cursor.execute the item. All right, and when I'm all done, I'm going to say connection.commit. Let me return to my file manager, and we can see now that this mydb.sqlite file has 12 KBs worth of stuff in it now. Okay, as another way of doing the same thing, instead of executing separate insert statements with the values for provided for each of the employees in these separate input statements, I can actually create a sort of a template for doing the insert, like so. Insert into employees values, and then I just have these question marks as placeholders. This enables me to just have a list of lists or a list of tuples of just the data values themselves. All right, and I have done that also in my file, but because the employee ID numbers are supposed to be unique, I'm going to change the employee ID numbers here. Let me just say 7,000. And this Ben King, this is maybe the son of the primary Ben King. So these are all Ben King Jr., Larry Jones Jr., etc. And we'll have this Ben King report to 7839. 39. Here we're going to have 8,000, 3,000, 5,000, 4,000. All right, so that I don't, so that I have unique ID numbers, even though all the other information in here is the same. I'll copy and paste the creation of that list of lists. And now, notice, instead of going through and executing each insert statement in a loop, I can invoke the execute many method instead. I give my query, which in this case includes the question mark placeholders for the values, and as a second argument, I give the list of lists or list of tuples or tuple of tuples or whatever it might be to feed data into that insert statement. All right, so let me also copy and paste the query that I want to execute. And then I'm going to do the execute many. So cursor.execute many of that query, and the values for the question marks are going to be filled in from each of the lists in the data2 list of lists. All right, and again, I'd better commit this to make sure that it stays. And let me take a peek at my file manager again, and interesting. Okay, so it's still 12 KB. It may be that what's going on here is that the size of the database just grows in maybe 6K or 4K buffer size chunks, and that I still have not completely filled up that 12 KB yet. As I continue adding more and more records about more and more employees, I will eventually occupy more space. Okay. This is just an alternate way of using a for loop on execute to just execute the query one item at a time. It accomplishes the same thing as the execute many that we just looked at. Now that we have data in our database, we can actually try out a select command. And previously we looked at, well, let me copy and paste this version. So previously, we said things like select manager. I've forgotten the names of these fields. Let me go back up and look. Okay, manager, month sal. No. So select manager, monthly salary, L name from employees, and that would just select just those three columns. But if I want to see all the columns, I can use star instead. And so that's what's happening in this example. Select all the columns from the employees table. Let me make another comment here, which is it's typical in SQL statements to break out the statements in this structure. You say select, and then the columns that you want to select. And then separately you say from, and the table or tables that you want to select information from. And then where, or in this case on, the attributes that you want. But all that SQL really cares about is that these tokens occur in an acceptable order. And so for a really short select statement, it's perfectly fine to just do the select and the column names and the from and the table names all in a single line. And in this case, I want to see every single employee, so I don't need to have any where clause at all. All right, so that's the query I want to execute. And when I do execute it by saying cursor.execute the query, it appears that nothing very interesting happens. But in fact, my cursor has now been sort of positioned at, if you will, the result of this select statement. And I can fetch all of the rows resulting from that select query. So I'm going to say, on the slide here, on slide 24, it's been split into two separate parts. I'm saying rows gets fetch all, and then for row in rows. But I can just do for row, let me say for emp in cursor dot fetch all. Okay, fetch all is how I get all of the rows in that table that results from doing the select, and I can say print the employee. And there we go. Okay, so I've got my 8 fields of information about the 10 employees in my company. Makes sense? And you all answer yes, I can tell. Okay. It's also possible, instead of saying fetch all, you can fetch a certain number of rows, or you can just fetch one row. Let's try that. So if I say, let me re-execute my query so that I refresh my cursor to get this table, and I can say while well, let me just print cursor dot fetch 1. There we go. And then each time I do cursor.fetch1, that's going to get the next one and the next one until eventually, after I've done this 10 times, whoops, eventually, when I get to the bottom of all of them, I get none. Okay? So that's an alternate way of fetching the matching rows just one by one. And I didn't mention, but let me mention here that notice that each of these rows that we get back is stored in a tuple. Okay, so we're getting tuples back from fetch all or fetch many or fetch one. Well, this looks very much like a data frame, and indeed we can create a data frame from the rows that we've got. Now, I did not create this rows variable, so let me do that. I'm going to say cursor.execute the query again to make sure that I refresh where my cursor is. And now I'm going to say rows gets cursor.fetch all. So rows is now a list of tuples, and I can use that list of tuples to provide data for a data frame. I can also ask for the cursor description, which will tell me the attributes of the table. Sorry. Lost my train of thought there for a minute. And so in each record that we're getting from the table, the first field is the employee number, the second field is the last name, third field is the first name, et cetera, et cetera. And so if I say, let's create a list of name sub 0 for name in cursor.description, that's going to generate for that. There's a list comprehension, and from the cursor description, which is going to be this tuple of tuples, I'm going to select out each tuple, and then name sub 0 is going to be the sub 0 item within each tuple, which is going to give me empno, lname, fname, job, etc. And those are what I want to be the columns in my data frame. Okay, so here I am now. I'd better, actually, I just realized, I had better import pandas as PD before I try this. And let me also just, out of paranoia, import numpy as np as well. And now I can create my data frame. I don't like where that line break occurs, so let me, there we go. All right. Okay, so rows is my tuple of tuples, or my list of tuples, I should say. This, what I had up here was a list of tuples. So rows is a list of tuples for the data. And then columns is the names of the columns. And I have now successfully created my table as a data frame. So the font's a little large there, but it is a data frame with those 8 column names. I didn't specify any index values, so I'm getting the default 0, 1, 2, and so forth from here. Now, it should be, I hope, clear that you can go the other direction as well. You can pull the rows and column names out of a data frame and use an SQL create table and sequence of insert statements to create a table in your database and populate that table with the information that you pull from the data frame. Okay, so that was a quick example using Sqlite. There are lots of other SQL databases out in the world. MySQL is popular. PostgreSQL is popular. All of these have Python modules that you can install and then import into your Python code in order to interact with them. And so forth. I don't actually have these to demonstrate, so you can play with these things yourself. I do want to do just a little more demo because In the part of homework 3 that we did not do, there was this database called libooks.db, and despite that it has a .db extension instead of a .sqlite extension, libooks is also a SQLite database. So I can say, and let me copy over the code that I have already written so I don't make silly mistakes. So I can connect to that libooks database, and I can create a cursor through which I can talk to that database. And now here is this select command that I showed you earlier, but since we didn't have any tables created at that point, or we didn't have any, we didn't have any databases, we didn't have any tables in our database at that point, I couldn't actually do it. So this time I'm actually going to execute this statement here that will show you the tables that are found in the libooks.db SQLite database. And I'm going to display each row now that I've got that cursor set up. Whoop. I didn't copy and paste. So for each row, in fetch all from the cursor, there we go. So these are the individual tables in that, what was it called? In that libooks database. We've got several tables in there for employees, customers, orders, publisher, author, books, and et cetera, et cetera. So that will, I hope, give you a boost insofar as doing that part of the homework that we were unable to do last week. All right, well, that was short and sweet. And we'll move on to part 10 next week.